The video, we're going to show it to you now before you get to even see it tomorrow, which is pretty cool. And then after that, I'm going to actually talk to a couple of people that are involved in the work and also kind of some of the behind the scenes stuff that you're going to see in the video. And I'm going to do just a quick interview with them, and we're going to open it up to the audience for more Q&A. So if you have really tough questions, today's the day to grill a student. Brad, I'm sorry about that. But we welcome your questions and look forward to your thoughts around this wonderful work. And I also want to mention we are streaming live on Facebook, and we're also going to have somebody joining us digitally. So just a really interactive, exciting event. Thank you again for joining us, and enjoy the video.
For most people, the human heart beats about once every second.
Keeping time and keeping us alive.
I never thought about this until I discovered my heart was failing and I needed a new one to keep living. Now all I think about is time.
Will I get a new heart?
Will I get it in time?
And how much more time will it give me?
Clear for takeoff. Stay with me for now.
In the United States, donor hearts are considered usable only if the transit time is less than 4 hours. And every year, thousands of hearts are discarded before transplant because the transit time between the donor and the recipient is too great.
At the University of Notre Dame, engineering professor Pinar Zorlatuna is working to extend the time donated hearts can remain usable through cutting-edge cellular research.
The special thing about Professor Zorlatuna's work is that she builds the closest thing possible to a human heart in the laboratory. This allows us to test the function of our preservation solution and of transportation.
In collaboration with Dr. Keith March, Professor Zorlatuna has helped to identify a solution that will improve the condition of a donor heart and extend its preservation time from 4 to 8 hours.
Each donor heart represents a special gift, and our efforts at Notre Dame are designed to ensure that more of these gifts reach those who need them most.
I'm Eric Lewis. I'm 24 years old and I've been waiting for my heart for 5.5 years.
I'm still waiting for a heart transplant.
I'm still waiting for my heart transplant.
The University of Notre Dame asks, what would you fight for?
Fighting for the human heart.
We are the Fighting Irish.
I wish I could take the credit for that, but I absolutely cannot. That video is produced by the university's Marcom team, and Beth Grizzoli is here and is just a wonderful partner and has helped us throughout the season in previewing these Fighting For videos. So if you could, please join me in giving Beth a huge round of applause. Thank you, Beth. I also want to introduce our two guests today. Live streaming from Indianapolis, Indiana, is Kellie Hanner. Kellie is the president and CEO of the Indiana Donors Network. And also Brad Ellis, if you could join us here at the front. Brad is a PhD student here at the University of Notre Dame, working in Professor Zorlatuna's lab. And Professor Zorlatuna wanted to join us today, but she was not able to and sent Brad in her place. So thank you, Brad, for joining us. Thank you, Kellie. All right, so Brad, come on up here just a little bit. Awesome, thank you. So Kellie is going to give some really great perspective and some background information on what you just saw. And I really want Kellie to kind of help set up the stage for us. So give us some background information about organ donation, specifically heart donations. How many people are in need of heart transplants, and how many hearts are actually used for donations each year? Can you hear us, Kellie?
I can. Well, currently there's over 115,000 people waiting for a life-saving organ transplant. Now, the majority of that is kidney transplant, but there are over 4,000 people waiting for heart transplants. In Indiana alone, that number is somewhere around 100 or so, but 22 people die every day waiting for a life-saving organ transplant. And only about 1% population dies of brain death, so that's why the need is so great.
Wow, that's incredible. And Dr. Zorlatuna also mentioned that there's a limited time frame in which a heart can be transplanted for recovery. Can you talk a little bit more about that and give some more background information on that?
Yeah. The time that the organ is recovered until it's actually transplanted into somebody is called cold ischemic time. So that is the 4 hours or so that they were talking about in the video. So that really creates a geographic disparity as far as if the donor's in Indiana, how far you can take that organ out of state to be transplanted, or to bring an organ in state to be transplanted. So it really does create a geographic disparity for us. But the nice thing about it is that we do have a subsidiary company where we own our own jets, and we're able to get organs faster to places than we ever were before.
And that's what we saw in the video, correct? Were those jets?
Yeah.
Okay, very interesting. Oh, go ahead. Anything else that you wanted to add to that? Sorry. Yeah, there's a little bit of delay. I just want to make sure I didn't cut you off. So this gives kind of a good groundwork for why this is so important, why this research is so important. And Brad, we're so pleased that you could be here. Can you tell us a little bit more beyond what we saw in the video about what happens in this lab that you're in?
Yeah, sure. So our lab is what's called a tissue engineering lab. So basically we use biological tissues, cells, et cetera, with engineering methods to kind of develop ways to study the human body on the benchtop without using animals or clinical trials. So we specifically study cancer and cardiovascular disease. Specifically what I've been working on has been with this, essentially it's a solution with a bunch of ingredients and goodies that can help organs stay happy, healthy, and alive longer during this cold ischemic time that we were talking about previously. So
what exactly is it that you do in the lab then?
So exactly what I do is I've been developing and testing what we call an in vitro or benchtop model that we can use to test this solution, again, without using animal models or without using doing a clinical trial. So it allows us to kind of understand exactly how this solution is working and exactly what it's doing before we actually would move on to more costly clinical models that would, again, cost lots and lots of money, or just, again, you would need to have a lot more knowledge and information about how that actually works before you would want to go into those studies.
Okay, so I guess when I heard about this, I was surprised, I think, to hear that this was happening at Notre Dame. Not that Notre Dame's not a wonderful place for this kind of cutting edge research, but first off, you're an engineer and you're working with the human heart. So can you tell me what is it that you're hoping to accomplish, and a little bit maybe on why you even got into this here at the university?
Yeah, sure. So what we're really hoping to accomplish is to first off, I guess in the immediate future, is to completely understand exactly what this solution is doing, exactly how it's working. So that way we can kind of optimize it, either by adding ingredients or taking away ingredients. And then once we have that figured out, basically trying to make it work as best as possible in a simple benchtop model, and then increase that complexity through, again, using tissue, through engineering methods, essentially, where we can make more and more complex models on the benchtop, so we kind of have an exact idea of how these cells are working, how this stuff is working with human cells before moving on to clinical trials, so we have a much better idea of what to expect, so we, again, can alleviate that cost and hopefully alleviate any issues that could arise from using this solution before we actually get to where it's going into patients. As for how I got into this research, I was lucky enough during my undergraduate degree to do research in cardiovascular disease, so I kind of had an idea that I knew I wanted to do something in this field, and I just was really just a perfect mesh. So I'm natively from Indiana, so I always knew Notre Dame was a pretty cool place to go to. And within the past decades, it's been, like $150 million in funding just for scientific and engineering research. So I always knew that, like, in the back of my head, like, Notre Dame was really a good place to go for research. And with Dr. Zorlatuna's work, it kind of just was a perfect combination of what I was interested in and somewhere that I wanted to go where I would be able to look into what I was interested in, what I felt like could do the most good, and just basically getting to come to Notre Dame as well, which is pretty cool.
So one thing that we talked a little bit, I mean, obviously Dr. Zarlatuna couldn't be here. Can you just give us a little bit of background into what she does and also why she's here? Any kind of tidbits that you'd like to share with the audience?
So I guess, so what she does is she's has been working for probably the past 15 to 20 years, give or take, on tissue engineering. And basically what she really would like to do is to develop methods or materials, devices that we can use to study disease, again, on the benchtop without having to use animal models that can, leave you in an ethically dubious area, or before doing clinical trials where you, again, have that extreme costs associated with that. So it's basically more of trying to find the most cost-efficient method as well as the most ethically efficient method for studying the diseases, specifically cancer and cardiovascular disease. Cost-efficient method, whereas you can, I'm trying to think of how to end this, with just, I guess, in the best method possible.
Sure. Yeah, that makes sense. So, okay, this gives us lots of good background information about the work that was done. I'm curious if we could kick it over back to Kellie. If you could give us a little bit, we saw, you'd mentioned that there was jets that transport hearts back and forth. Can you give us just a little bit more behind the scenes on what happens with an organ donation and also the transportation itself?
Sure. It's actually a pretty complicated process. The Indiana Donor Network is responsible for coordinating organ tissue and eye donation for the state of Indiana. And so when a patient comes into the hospital, and again, only about 1% of the patients are actually medically suitable to be organ donors, which is why the list is so high. We work with through the process with the families. If the patient has designated themselves to be a donor, then we move forward with the process with the family, or we approach a family for authorization for donation. Once that is done, then there is a valiant of tests that have to go on to determine if the patient is suitable and which organ they are suitable to transplant, such as the heart. Then there is a matching process that takes place. Generally, the patients that are matching are here locally, and then it goes out regionally and nationally. And then once all of the organs are placed with the various transplant centers, then we coordinate the operating process where the transplant centers are actually brought to the hospital. The patient is taken to the operating room just like any surgery, and the organs are recovered for transplant. And then the organs go back to their respective transplant centers, and the organ gets transplanted and hopefully saves the life of the recipient for many years to come.
Yeah, we saw some really great examples of people that are waiting for hearts. Obviously, something that is so incredibly important. And I guess, Kellie, my question would also be, before I open it up to the audience, what should people do if they want to be an organ donor? What should they do?
Well, there's a couple different ways that people can register their decision to be a donor. They can do that at BMV when they're renewing their license or getting license plates or anything like that. They can go to our website at indianadonornetwork.org, or they can go to donatelifetoindiana.org.
Thank you. Terrific. I am going to open it up to the audience. Before I do, one last question for Brad. Kind of I know obviously what's next for the lab. What's next for you? You've been here for a few years now. What are your plans?
So I got about 1 to maybe 2 more years before I can I'll finish up with my PhD. Then afterwards, I would like to go on to what's called as a postdoctoral fellow, where I'll essentially continue my training in research, and then for probably another couple of years after that, and then finally, hopefully someday, get to be a professor and head my own lab where I would like to continue doing research with organ donation.
Sounds like you've got a great start here at the University of Notre Dame. Does anybody have any questions? We've got one right over here. Oh, hold on one second. I'm going to give you a microphone. Josh, there you go.
Were you, from the video, it sounds like you guys have been successful in actually extending the time from 4 hours to 8. Is that correct?
That's correct, in a cell model. So basically a benchtop model. We have yet to, so with these things, you have to prove beyond a shadow, essentially like beyond a shadow of a doubt, that this is going to most likely work in the human body before you actually get that approval for clinical trials, then you'd have FDA approval as well with that before you actually get to use this in a clinic. So unfortunately, yes, it's a very arduous process, but which is probably a good thing. So you don't have those issues, you don't have any unseen side effects, but that does, with that come a lot of time with having to do all these tests, with having to make sure everything works exactly how we expect it to.
So how long does it take to get that approval to start testing on real human people, and would you be part of that?
So I would say roughly, give or take, probably from the start of the research to where it could be clinically implemented, about a decade, maybe a little bit more than a decade. It takes a very, very, very long time. At least personally in this lab with this project, I would not get to see the end of that where it is individually put up to the patient. But again, as I would like to continue working with organ donation, I would hope to continue throughout my career to work with Dr. Zolotuna so I can see how this does come to fruition.
Another, I think you had, oh, back here?
How large is the lab here? How many doctoral students are there?
So our lab specifically, we have five Ph.D. students. We have 3 postdocs, and then we also, one thing that's cool with Notre Dame is they do promote undergraduate research as well. So we have about another 3 to 4 undergraduate student researchers as well. So total maybe 15, give or take, a few people.
Are you in Stinson, right?
So we're at what's called the Multidisciplinary Research Building, which is basically the far north side of campus by where the maintenance building is. So if you go up to Douglas Road and take it all the way to end where there's St. Joseph Drive, you'll see our lab. We're right by the maintenance building. So yeah, how the heart currently is transported is it's put in what's called a cardioplegic solution, which basically lowers the metabolism of the heart and protects it from everything that is trying to injure it during that transplant. So what we're trying to develop is essentially an additive to that. And currently right now we're using stem cell derived culture medium. So it is, yeah, like you said, that culture fluid that you use with the cells. And they have a lot of antioxidants and just other molecules that really will promote cell health, especially during what's called ischemia or what's called also reperfusion. So basically anytime that the heart is being damaged due to either oxygen or a sudden influx of oxygen. And I think eventually what our main goal is probably not so much to use that solution itself, but to find the ingredients in that and then add them into it, into our own solution, so we're not using something derived from cells where you can have a little bit less control on the exact numbers that you have. Whereas if we're adding into our cells, we know exactly how much we're going to add, and we know exactly what we're adding as well. We don't have any unseen things in there.
Still be used for your research testing and the next stage getting away from the bench top?
With Dr. Keith March in the video that we just saw, he has an ongoing approval with the Indiana Donor Network, where together we're able to, if the heart is not viable for transplant, we're able to recover that heart and we can actually use it for research purposes, either to compare to our current model that we're using or to better understand what's going on with those hearts, why they weren't able to be used, and how we can try to make them usable in the future so we get less of them, hopefully.
With the extension, possible extension from 4 hours to 8 hours, that doubles the time, obviously, but with logistics, I imagine a lot of the time is spent, getting to the airport, with an extended period of time, practical to harvest hearts from more rural places around the state. Obviously, if you're in Indianapolis, you've got a state-of-the-art hospital there, and even here in South Bend. But if you're in the middle of the state, is that where the extension comes to widen the geographic area where you can maybe harvest a heart from?
I think that might be a question for Kelly. Did you hear that,
That's
Kelly?
right for Kelly.
I heard a portion of it, so if you could repeat it, that would be great.
So it sounds like the main question is it better to kind of harvest the hearts from rural areas?
Right, it gives you a larger area to get donor, all donor organs from in the heart.
Okay. So most patients that die, that become organ donors, are dying of deaths such as strokes or MVAs or things like that. And so those patients are generally taken from a rural hospital before their death to a main hospital or a main city, such as Indianapolis or South Bend. All of the rural areas, most of them have a somewhat close airport that we can fly into as well. So we can really go to any hospital in the state of Indiana to recover organs, but the majority of our organ donors come from a very select few hospitals just because they are a trauma center or have a higher level of care.
Good question. I think we are actually, believe it or not, already almost out of time. I just wanted to say a very special thank you to Brad and Kelly too. Thank you for joining us. And a sincere thank you for the hard work. I know, like, we had somebody ask how long this takes. It's diligent work, and it is baby steps, but if somebody doesn't do it, then where are we in 10 years? So thank you again. Thanks for your work. Thanks for joining us today, and on behalf of the Alumni Association, thanks to everybody here that joined us.